In July 2026, a small power plant in the United Kingdom quietly went completely dark. For 4 days, the facility produced zero electricity, disabled by hackers linked to the Iranian regime. Because this was a 15-megawatt gas-fired peaker plant, a small site to handle sudden spikes in demand, the outage never threatened the wider grid. Government officials publicly dismissed the incident, with one source describing it as less than a rounding error compared to grid capacity. Cybersecurity experts, however, viewed the small capacity as a distraction. The critical failure was the loss of physical control. A hostile state had successfully manipulated British hardware from a remote terminal. The most significant detail was the recovery timeline. Even at a facility this small, it took operators 96 straight hours to regain control and restore the plant to an operational state. This 4-day outage serves as a successful proof of concept. Hackers proved it could bypass digital defenses, hold British infrastructure offline for days, and execute a physical disruption from thousands of miles away. The UK breach occurred alongside a wave of similar activity across the Atlantic. In late July 2026, Iranian-linked hackers targeted wastewater treatment plants in 12 U.S. states, causing flooding and localized water shortages. These events raise a technical question. How does a digital threat bridge the gap to force heavy, physical machinery to stop working? To find the mechanics of the UK breach, we have to look at the historical blueprint for industrial cyber warfare, the 2015 Russian hack of Ukraine's energy grid. That attack began 6 months before the outage with a targeted phishing campaign. An employee opened an email and enabled a macro in a weaponized document, granting the attackers a quiet foothold inside the business network. Once inside, the hackers spent months mapping the infrastructure. They moved through the administrative network and stole credentials until they found secure VPN tunnels connecting the office computers to the industrial controls. Their ultimate target was the SCADA system. This is the digital bridge that translates network commands into physical actions, such as opening a circuit breaker or closing a valve. Modern grid warfare relies on hijacking these administrative credentials. By blending in with legitimate traffic, attackers can reach the control room and manipulate the hardware from within a trusted session. In Ukraine, the attackers finalized the shutdown by deploying kill disk malware. This software wiped the local workstations, ensuring the human operators were blinded and locked out of their own systems. With the operators unable to intervene, the hackers used the digital interface to remotely open circuit breakers at 27 substations, instantly cutting power to the region. The July 2026 UK breach followed this same pattern. Attackers bypassed outer defenses, gained trusted access to the controls, and issued a shutdown command. Peaker plants are specifically vulnerable to this tactic. Because they are designed to balance sudden spikes in demand, they are often small, unstaffed, and built to be triggered by remote signals. Hacking an automated plant is a successful demonstration of exploiting these remote triggers. It proves that even the most modern automated assets can be turned against the grid they support. The National Cybersecurity Center, part of GCHQ, has tracked a sharp rise in nationally significant cyber incidents, managing over 200 attacks on critical infrastructure in just the last year. Security agencies now operate under the assumption that preventing every breach is impossible. With high-capability state actors constantly probing for weaknesses, a perimeter breach is eventually inevitable. This risk is growing as the UK moves forward with its Clean Power 2030 initiative. To reach net zero targets, the nation is rapidly decentralizing its electrical grid. We are moving from a system of a few massive power stations to a grid made up of thousands of small, automated nodes. This transition transforms the grid into a landscape of thousands of smaller entry points, lacking on-site staff to monitor for physical interference. National security must now move beyond absolute prevention and focus on business continuity. If a breach is inevitable, the priority shifts to how the system survives the attack. The ultimate metric of safety is now the speed of manual recovery. The goal is to ensure physical operations can be restored by human staff, even when the digital networks are completely compromised. Government agencies are already urging businesses to prepare for a total blackout scenario, where systems fail and screens go blank. The 96-hour recovery in July was a warning. The next incident will be a critical test of national survival.